Alright, so we are going to move into interaction of electromagnetic waves with dielectric boundaries. Okay, again I would like to show you this experiment that should sort of excite you as to what is this puzzling nature of electromagnetic waves, right. So, let us watch this video. Absolutely fascinating, isn't it? So, let me try to explain what is going on. Okay. So, I essentially have a simple glass pane, okay, and I have a little flash lamp, right. So, your high school physics taught you that surfaces, right, or dielectric boundaries can cause reflection and refraction, right. So, this is basically the reflection and the image, you can either call it transmission right, or basically it undergoes refraction as it goes into the glass, right, but the glass pane is finite, right, it has a certain thickness. So, I can certainly look at the transmission okay, and the reflection in the video. Right. So, this is not very surprising, right. You have seen this many times. You walk in front of a glass pane, you can sometimes see your own reflection on the glass pane and you can also see through, right. So, some light that is bouncing off of your face is getting transmitted through into the room and some of it is getting reflected back into your eyes, right. But what is bizarre was when I introduced a polarizer plate in the path of this beam, right. So, remember what does a polarizer do? Okay. The flashlight that I have is a source of unpolarized electromagnetic waves, and the polarizer, based on its axis or orientation, would essentially ensure that the electric field oscillations are oriented in the same direction as the axis of the polarizer. Okay. But what was bizarre was this reflection completely disappeared when the polarizer was rotated. Right. So, if you can sort of rewind and look at that carefully, you will notice that the reflection spot, right, of the flashlight will completely disappear when the polarization was rotated by 90 degrees, right. So, merely by changing the state of polarization, right, that is the axis of polarization of the electric field that is allowed to interact with the glass pane, I am able to control whether the light gets reflected or not, right. Seems like a very bizarre phenomenon. So, the same situation, if I were to keep the polarizer plate in this direction, right. So, we will have to somehow explain what is going on, right. It is important that we try to understand this bizarre phenomenon of electromagnetic waves, which is saying that if I were to purify, right, by filtering an unpolarized source and only send polarizations of certain orientations, right, linear polarizations of certain orientations, I notice that some orientations have little to no reflections coming off of the glass pane, right. So, this should be quite a bizarre phenomenon for you, right. So, before we dive into the mathematics, I just want you to understand high school taught you how the light beam, right, or any electromagnetic wave, when it interacts with a medium of different permittivity or mostly permittivity, right, or a different refractive index as you call it, you understood that the light waves slowed down or got refracted, right. So, high school taught you how the beam of light reoriented upon entering a new medium. Right. So, high school already taught you this, right. So, this is also considered as the Snell's law, right, which says that if a beam of light were to be sent into water or glass, you know that the beam reorients itself, right, and you were told what the equation of Snell's law was, right. So, we are going to revisit this electromagnetic waves interacting with dielectric boundaries here, but you need to understand what is it that you are going to learn that is different from what has already been taught to you in high school, right. So, now we are going to try and answer a few different questions, right. So, the first one is, right. So, high school only taught you how the beam reoriented, that is, it was mostly about direction or orientation of the beam, right. It just taught you angles and the relationships of the angles based on the input angle, right, and the refractive indices, but it never really taught you how to estimate how much light got reflected and how much got transmitted or refracted into the material, right. So, we will definitely derive relations mathematically to give analytical expressions, right, for the reflection and refraction. We will also look at the basis for Snell's law, right. So, that relationship that was taught to you, we will see what is the basis for it, right. We will notice that it all comes or stems from the electromagnetic boundary conditions, right. And last but not the least, we will also see the polarization dependence. Okay. This is perhaps the fascinating part of electromagnetic waves, in my opinion. This should also clarify as to why we are seeing what we are seeing in the video that I just showed you. Okay. So, let us be very clear that we are equipping ourselves with more skills, right, and this complete set of Maxwell's equations is actually able to paint a much more accurate picture of what is happening when electromagnetic waves interact with dielectric media, and it is giving us much better insights than what was merely taught in high school, right. So, now I would like to share the same experiment, but with just a small change. Okay. So, the only difference in this experiment is that instead of inserting the polarizer in front of the source, I am inserting the polarizer in front of the reflected beam. Right. And I also notice the same sort of outcome, right, which is to say that as I rotate the polarizer film, right, and its axis by 90 degrees, I notice that the image on the wall cancels, right, or completely is darkened, right. So, I highly encourage you to maybe just think through the repercussions, identify what is particularly different between the two experiments, right. How does placing the polarizer in front of the source as opposed to keeping the polarizer in front of the reflected beam, how is it different, right, and what is it trying to teach us, right. As we go along doing the detailed mathematics of understanding how electromagnetic waves interact with dielectric media, I want you to try and answer these two experiments. Okay.